So this may seem strange, but have you ever thought about this idea? Have you ever wondered how a computer is able to do a curve fit that you might have had to do by hand in one of your introductory science courses? And also, have you ever wondered why light behaves a certain way as it propagates through different media? And at first, those two questions seem extraordinarily disjointed. As it turns out, they're actually very much related. Hi, my name is David Hoxie. I'm a computational physicist. My PhD was in applying machine learning to find better ways of optimizing nanophotonics. That's basically a long-winded way of saying that we were trying to make better LCD screens. Or this is going to be a new research model. It's going to try to look at a partnership between a human researcher and an artificial researcher. And that's going to be Google Gemini. This is just documenting how we can try to find ways of not only giving back to the education community, how could we maybe utilize AI to help with peer review processes, etc. To kick things off, I wanted to show you a few concepts that links all of this together. Here, I'm just going to demonstrate how we can take a system of springs and by changing the strength of the springs, we can change the way that the system looks. If I change any of these, the entire system responds. And this is exactly the process of which once we get this thing to sit back to an equilibrium, which is learning, that's the process of learning, and machine learning is letting the system come to an equilibrium state. So we're taking in information, we're transforming that information to a new state. Let's say that I make a more difficult line for it to follow. What you're seeing now is the line, which is a bunch of neurons, has to move its weights to a point such that it overlaps the input data to reduce the amount of free energy in the system. Well, I shouldn't say that. It depends on the loss algorithm that you're using. But the point is that it's trying to minimize the energy, right? It's just a ball rolling down a hill or a coupled set of springs coming to an equilibrium. And as I add more data, you can see that the system is able to reconfigure itself. And that this is why, I was saying that uncertainty is actually a little bit better, because if you have a single knowledge point, you're stuck in this hole that you can't get out of. If you have a lot of flexibility, you're able to better generalize. So as we just saw, the arrangement of dots you saw was completely determined by the different weights, and we had to manually move the weights around. And then in the second demo, we saw that, well, you could do it computationally. And this is the idea. So basically taking a system that is out of equilibrium, letting it move to an equilibrium state is the process that what physics we would call just relaxation. In other terminology, they'll call it learning. What we're looking at here is just trying to find how else we can use AI in the research process. Can we use AI as a collaborator? Can we use AI to help us formulate various things for educational content? And that's what I'm going to be exploring here. So if you are interested in any of this, please follow me on my website. Welcome and thank you.